Afternoon.
Hello there.
All right, so we're going to go through test 2 spring 2011. Somebody was kind enough to provide a key for the fall of 2009. So that one has already been posted. So I would appreciate if somebody could post this key as well, but I'm going to go through it. So when we're going to do this kind of problem, there's actually two ways that we could possibly do the mechanism for this. I'm just going to show you one way, but the other way is also possible. That would be adding the H plus first to a double bond. So that would be one way of doing it. Remember, you get a full point if you can, a full bonus point if you can do the completely correct mechanism for any of these. Remember, there's no naming either, so just ignore the names, just as we did previously. Now with the Grignard reagent, so you draw it out and you put a, let me be a bit more consistent here. So the negative charge goes on the C that has the Mg on it. Then the arrow comes into the C that's part of a C double bond O. And you can see we've got 1, 2, 3, 4 carbons. So 1, 2, 3, 4 carbons get added here. And then we add the H plus, and that gives us our product, which is going to be this one, of course. Does anybody have any questions about 1 or 2 here? Parts A and B, if you will. Okay. So this one, you've got what amounts to a tertiary carbon on the left-hand side of this structure. And the first step here is this enol step. And then the bromine can get added to that. And I think I also had, all right, let me be a little bit more obvious about that. I want to be real clear, because I wouldn't allow you not to be that clear about it either. You really do need to show that bond breaking simultaneously. I mean, that would give the product here. Let's see, that's 1, 2, 3, 4. 1, 2, 3, 4. Make sure it's 1, 2, 3, 4. Okay. And I guess you'd have H plus and Br minus, which would form HBr if you wanted to, but we can just leave it at that. Let's see. 1, 2, 3, 4. Yeah. Okay. Does anybody have any questions about that one? Bromination. Okay. Now this one has a primary on one side and the tertiary amine on the other. We never dealt with anything to do with tertiary amines. But the NH2 is what's going to do the attacking here, and not the N that's, attached to the other side here. So that's the nitrogen that's going to attack you. And you might be asking, well, how do you know that's going to happen? Well, there's a couple of reasons, but the main reason is that there's more. Well, first of all, there's two reasons. There's the fact that what we're going to get at the end is fairly stable. That's that imine with the C double bond N. The other thing is that the NH2 is far more exposed and is more likely to attack that C double bond O than the, I don't know, I suppose I can show the hydrogen here since I have in the, you don't have to show the hydrogen though, because it is an aldehyde. Okay. So we do that proton transfer, and then that last step there, where we form the double bond to the N. All right, does anybody have any questions?
Could you draw out the answer clearly to that? Because at the end, it's sort of.
Yeah, you don't think that's clear enough?
Well, let's put it this way. If you want me to hand in the key and have it correct, I'd like to see the answer. If not, someone else can do it.
Oh. Gosh, Julie, all right.
I just want to make sure it's right. That's why I'm.
All right. Well, let me. I'll draw it a little differently. Is that okay?
Yep, thank you.
All right. Now the next one doesn't have a mechanism on it. And is just going to that's going to be the answer. So all you do in any of these situations is change the OH to a C double bond O. And that's it. Sometimes people make the mistake of thinking this is like an H, and they put a carboxylic acid group or something on the end there. But that's not what you're supposed to do. I mean, this is a secondary alcohol, not a primary one. So the answer is a ketone, a methyl ketone, but a ketone nonetheless. Does anybody have any questions? Okay. I don't know if I want to do the mechanism for this one right now. It's a pretty long mechanism. It is worth 2 points. So I think I'm going to skip that, but I will show you the product. It's a Wolff-Kirschner reduction. And that's what you get as the product. Does anybody have any questions? Okay. Likewise for this one, I won't show the mechanism for it, but I will show the products. And the expected products for this, well, for any of these, you need to show anything that's got carbon in it as a product. So you need to show both sides of this, which are going to be both the carboxylic acid and the CI3H. All right, does anybody have any questions? Okay. On this next one, the product is going to be this plus PH3 P double bond O. You need to show both parts of it. Now, if you're showing the mechanism, that goes for either of these, then you're kind of already showing the products and you're kind of getting the points by doing that and doing the mechanism. But again, I won't do the mechanism here, just at the interest of saving a little bit of time so we can make sure we get through the entire test. Does anybody have any questions?
On the test, if you show the mechanisms, you get extra credit though, right?
You get a bonus point, but it has to be completely correct.
Okay.
If it's not, then you don't get the bonus point. I thought about taking points off if you got it wrong, but I won't do. That'd just be evil, wouldn't it? Certainly force people to get it right, though. And you can leave the H on that's on the C that's attached to the OH. You can leave that there if you want to. Does anybody have any questions? Okay, this one here is a secondary amine. I will do the mechanism for this one because it's a possible mechanism for question 2, I think. Question 2 or 3. But I'm going to go ahead and do this anyway. Now this is a symmetric ketone, so it's worth saying. If it was asymmetric, we'd end up with 2 products. This is only going to give us 1 product. I didn't mean to go off the screen. All right, let me be a little bit more clear on that arrow. bit better. It doesn't matter which side we take the hydrogen from. Could be either side because it is symmetric. And we end up getting this as a product. So I'm going to draw this a little differently. Okay. Does anybody have any questions? I kind of flipped that over, puts it upside down. Or just that part here that has the double bond in it. Anybody have any questions about that one? Remember, if it was asymmetric, if it was different on each side of the ketone, I'd end up with two products. And you have to show both mechanisms there. So looking at this one, you know, if you can see, that's why this is kind of comparable to the one I did earlier. Let's see if I can find it here. Yeah, this one here where we had the NH2 with the two ends, sorry, the two pHs on the end. So we can compare that to this one, and that might have helped you to get the right answer on that other one as well, because now you have that answer in front of you, and that's going to determine exactly how you approach this. You can see the N with the two pHs here. It's clearly not the one that's attacking the C. It must be the NH with the pH that's attacking the C, which makes sense because that's what you expect to see anyway. Does anybody have any questions so far? So that's the kind of analysis you should be doing. You've got H2O here, by the way, as well. I'm not going to. Okay. So we're going to have the NH there attack the C plus, because we see the product here, we know which N attacked. It's a positive on the N. Any questions so far? Hang on. Let's finish off the arrows here. Okay.
I can't really tell where you put the arrows over. I know you put the O to the H, but then I can't tell what's going on between the N and the H. You've got
Okay.
some arrows in there, but I can't see what they are.
All right. One tip I could give you, Julie, here is look at the story of the arrows here in the previous part. That can give you a clue as to what's going to happen in the next part as well. That's a bit clear, isn't it?
Yes, thanks.
And we already see the product here, so we can just make sure that we do get that in the last step by taking a hydrogen off the C that's adjacent to the CN bond here. All right, does anybody have any questions? Now the H plus and the H2O at the end are necessary to be shown because this is a mechanism and everything needs to be accounted for. Does anybody have any questions about this one? All right, this next one, remember this next one could be a, all right, let's have a look at what the other product is. So that's plus H2O is the other product there, just showing you. So this is a formation one. The other possibility is the hydrolysis of the cyclic ketal and going back to the ketone. So remember, there is another product here I just haven't shown. That's the water. I can't see it here, but so the O joins onto the H plus using that mechanism. And that means that now there's a plus on the O there. Now we know the water is going to leave. We do see that as the other product. I know I'm not showing it, but see if I can. So we know the water is there as well. So we know that this next step with the proton transfer is going to happen. It has to in order to form that water. And then the water leaves. So you'll notice that as a pattern is anytime something gets protonated like this, it always seems to leave, right? Let's see where the water came off here. So that's where the water ends up. Let's see. Okay, does anybody have any questions? Any questions at all about that one? Okay. All right, let's look at this one. I don't think we've done this one before. Now, I outlined for you that the compounds that you'd be getting here were either going to be an aldehyde or a ketone. This one's C12H16O, or an aldehyde. Now, if it's an aldehyde, you see a 1H peak between 9 and 10. We don't see that, which lets me know that it's a ketone. Now, further, these kinds of peaks connected to the C double bond O are going to be between 2 and 3. With this one, we can at least get the double bond equivalence, and it's going to end up being 5 double bond equivalents, which is going to be indicative of an aromatic ring and a double bond somewhere else in the compound. The way I would start this is I would probably be, first of all, inclined to do a little subtraction, make sure that only the C double bond O is what's the only thing missing here. So C6H5, you've got CH, CH2, CH2, and then CH3 and CH3. So what I had told you about 6H's is that if it's 1, 2, or even 3 peaks, we're most likely looking at 2 CH3s, and if it was 4 peaks, you'd probably be looking at 3 CH2s. So we've got 6, 7, 8, 9, 10, 11. So there is just one C left. We've got one O left. And we've also got this 4 double bond equivalents. This is 5, which means we've got one double bond left over, which is likely the C double bond O. So that's the only thing that's not accounted for. And that's good to know. So then what I would do is I put the C double bond O down next, and then I would look at the ones that are furthest to the left, knowing that that's kind of what's connected there. So the CH on one side and CH2 on the other. Now the CH2 that I'm pointing at here is this one, the one that's furthest to the left. I believe that's probably closest to the C double bond O. And I can see from the 3 peaks that it must be next to another CH2, which would have to be this CH2 over here. Then the CH here, it has 1, 2, 3, 4, 5, 6, 7. So it has 7 peaks, which would indicate that it's connected to 2 CH3s. That's 6 adjacent hydrogens. Which makes sense because that 6H, which is 2 CH3s, is next to 1H. Does anybody have any questions? All right, does anybody have any questions at all about this? With the lettering, I'd be inclined to do A, B, C, and then you don't letter that because there's no hydrogen on it. D, E, F, and G. The 6H is going to be G. I think the 2H that's next to the C double bond O is likely to be E. The other one is likely to be D. And then the CH there is F. And then this would be A, comma B, comma C on the 5H. Does anybody have any questions? Okay. I think we already went through number 5 when I went through this kind of problem before, but I'll go ahead and just put the answer down just for the sake of completeness. You don't have to show any mechanisms for this one. So we know that the final product here is the C double bond O compound, and I believe that comes from an alcohol because this is clearly going to be a Grignard process somewhere in there because we've got this extra carbon chain in here. But this is going to look like with the OH here from the PCC. And then I would have to determine, well, what's being added here? Well, what's being added? Well, let's see. I'll circle this, which is the starting material, and that's going to end up being here. And what got added there was that 3 carbon chain. So that's going to be this Grignard reagent, which has 3 carbons on it. And second step H+. Does anybody have any questions? That shouldn't, let me be a little bit more clear with that. There shouldn't be anything there. It's just, there we go. That's better. All right, does anybody have any questions? All right. And this is a roadmap that I went through the other day. And again, just for the sake of completeness, I will show the products, but I won't go through the products because I did that the other day. And if you want to see that again, you can bring up the Zoom session. Okay, so let's see. Okay, so that's going to be A. This is going to be B. this one is going to be it's going to be C. This one's going to be D. And the last is D. And the last one, E, is going to be okay. Does anybody have any questions? That's E. Any questions? Okay. So that's pretty much the entire test there. I know there are a couple of mechanisms I didn't go through. If anybody wants to send it to me, they're more than welcome to do so. And, you know, I'd like it. The one I'll post will be the one that has correct mechanisms for the ones I didn't do. So, you know, I think it'd be good practice for whomever wants to do it to send that to me. Does anybody have any questions at all? Anything at all? All right. What about any test 2 related questions? Does anybody have any test 2 related questions?
Dr. Musgrave,
Yeah, Courtney.
for the mechanisms you went over in question 1, is that all the mechanisms we could possibly get?
I don't think so, because when I went over possibilities for question 1, I think that there might have been a couple that might have been other possibilities, like a primary, secondary amine was there, primary amine.
Like the ones we could get in problem 2 for the mechanism?
There might have been, you know, Courtney, I'm just trying to think. I don't want to be exclusive here, and
Yeah.
but there might be some that weren't mentioned, yeah. But I think I went through them all that day when I went through all the possibilities for reactions in question 1. But to be more,
Okay, you just said like, I feel like you said like other side reactions or something like that, and I was having trouble like finding them.
right. Well, let's have a look at this file here, problems test 2, and we'll look at the what do you call it, the reaction summary. Okay. So either one of those is a possibility for the oxidation, I can say that. Yeah, see hydration. I didn't see hydration or hemiacetal, hemiketal formation. Those are possibilities as well, Courtney. Acetal ketal formation. That's possible. Acetal hydrolysis. No, that's not possible for question 1. Grignard reaction. Yeah, we saw that. Reduction, primary amine, additional elimination. I'll tell you, reductive amination won't be on the test. Secondary amine, additional elimination will be. Wolff-Kishner, not on test 1, I mean. No, it's not on question 1, I mean. Wolff-Kishner reduction, that'll be there. Clemenson, that won't be there. Alpha halogenation, I think that will definitely be there. And iodoform, that'll be there. and Cannizzaro won't be there. All right. Is that?
So it seems, yeah, so it seems like the hydration, it's the hemiacetal or the one.
Yeah, the
that's
hydration and the hemiacetal and hemiacetal and acetal formation, and none of those were in this test, but you know, they could turn up on other tests. I mean, if you go through the other tests, you'll see those reactions there as well. But it will replace one of these, obviously.
Is that the one that's like the excess and the 1 mole?
Yeah, that's
variation?
right.
Okay.
Yeah, because you've seen those on other tests, right?
Yes.
Yeah, I don't think there was one on this test. So what must have happened is there must be a reaction on this test, but it's not on those other tests.
Oh, okay.
But when I did go through it, I know that I said it was a possibility to have the acetal or hemiacetal or ketal or hemiketal formation. Those are possible. To be super clear, that's going to be D and C.
Okay, thank you.
And even possibly A, the hydration one. That that is a possibility too. So A, D, and C. Those are reactions you did not see in this test, but are possible reactions that you might see.
Okay, thank you.
Okay. But that being said, of course, you may see those on other tests. Well, you will see those on other tests. So, you know, they're pretty much covered. I don't know what you're going to see on this one, though. All right. Does anybody have any other questions? Any other questions? All right, so along with this key, and you know, you all went through it with me just now anyway. So you know, you already have access to that. So even if somebody doesn't post a key, you all can look at the video. That would definitely help you with it. But I think it'd be better if somebody did post the key or send it to me so I could post it. That'd be good. But it's not entirely necessary because you all can go back and look at the video. Does anybody have any other test 2 related questions? So as it was last time, I'm expecting that you will access the file. I think I'll try and make it a PDF this time. I mean, I'm going to have to work on that a little bit, but yeah, I'll probably make that a PDF file this time. Make it a little bit easier to print out. Hopefully there won't be some pagination issues that some people had when printing it out. The other thing is there were a couple of people last time who had some real issues taking pictures and uploading pictures. I sent you an email that asked you to possibly look into some other apps that could help you with that. And I did give some ideas of apps that students had sent to me that are possible. And they're free possibilities for that. And I also invited you to even possibly post those to test 2 and make sure, test 2 Dropbox, and make sure that you could do it in a timely fashion. Most people can get this job done within 5 minutes, but there were people last time for whom it was taking like 30, 40 minutes to do, and that's just not acceptable. I never had that problem before, but last time I did. And I don't want to have that problem again, obviously. So it's incumbent on all of you to make sure that you have your ducks in a row and that you know what you're doing with regard to setting up those files. Does anybody have any other questions about test 2?
You said it was in our best interest to remember, learn and understand all the mechanisms, but the ones you said we don't need to know are number I and B, right? I'm sorry. I'm looking at the practice problems now.
Okay, can I show you? I mean, yeah. Looking through, I mean, I'll be real clear, Jasmine.
Okay.
Yeah, reductive amination, that won't be on the test at all, okay? Clemmensen reduction, L, that won't be on the test either.
Oh, okay.
Okay. And Cannizzaro, that won't be on the test either.
Thank you.
All right.
Mhm.
I want to be as transparent as I possibly can be here. Not asking you to waste a bunch of time here, studying things that won't be on the test. All right, any other questions? Anybody got any questions? All right, well, I guess we'll leave it there then, and good luck. Make sure, if you haven't started studying yet, I think it'd be a good idea to do so. It's honestly, some of you might get away with a day of study on this one. It's possible. This would be the only one you'd probably get away with it, but yeah, you might get away with a day of study on this one. But I would certainly use this as an opportunity to really score some points and run up the score, if you will, get the highest score possible, so that even if you are taking the final, you have to get less on the final to get the grade you want. And now it's a golden opportunity. There's not that many reactions to learn, and I think that it's a really good foundation to get those mechanisms under control. All right, does anybody have any other questions? All right, then we'll leave it there. And if anybody wants to hang around and talk to me, they're certainly more than welcome to do so. Okay, have a good day, have a good weekend, and I'll see
Thank you,
you
Dr.
all on
Musgrave.
Tuesday. Thank you.
Thank you.